Just before sunrise on January 28, 1986, Kennedy Space Center was colder than anyone expected a Florida launch site to be. Ice hung from the pad. Overnight lows dipped below freezing. The shuttle Challenger was already days late, and schedules were tight. The night before, engineers at Morton Thiokol warned that the solid rocket booster O-ring seals lost elasticity in cold weather and might not seal at liftoff. In a late teleconference, they urged delay. Managers at NASA and Thiokol ultimately accepted the risk and cleared the count. At 11:38 a.m., Challenger lifted off. Within the first second, high-speed cameras caught brief puffs of dark smoke from the right booster's aft field joint. Hot combustion gases had blown by the primary O-ring before pressure forced soot and aluminum oxide to form a fragile temporary seal. The climb continued. At about 59 seconds, a bright flame appeared on the right booster near that same joint. The jet burned like a cutting torch into the adjacent external tank and the strut that tied the booster to the tank. Liquid hydrogen began leaking. Aerodynamic loads increased as Challenger accelerated through strong winds aloft. 73 seconds after launch, the external tank lost structural integrity. Liquid oxygen and liquid hydrogen rapidly mixed. The airframe experienced forces it was never designed to survive, and the orbiter broke apart in the sky. The two boosters, still under thrust, veered away until their range safety charges terminated flight. Debris fell into the Atlantic. All 7 crew members were lost. In the weeks that followed, the Rogers Commission reviewed telemetry, film, and hardware. The finding was direct. The right booster joint had not sealed because the O-rings were too cold to respond at ignition. Heat and pressure eroded the seal, allowed flame to escape, and led to the tank failure. Contributing causes were also called out. A joint design vulnerable to rotation under pressure, poor understanding of how temperature affected the seals, and a decision process that discounted engineering objections. During the hearings, a simple demonstration drove the point home. An O-ring sample placed in ice water turned stiff and slow to rebound, exactly the condition feared on launch morning. NASA halted shuttle flights for 32 months. The booster's joints were redesigned and thoroughly requalified. Launch rules were tightened, temperature constraints clarified, and communication lines between engineers and management were rebuilt to surface dissent rather than suppress it. Challenger's loss remains a case study in how technical margins and organizational judgment can fail together, and how both must align when the stakes are life, vehicle, and mission.